Hello and welcome to this section of the Algebra Tutor. Here we're going to continue where we were leaving off in the last section dealing with dividing polynomials. In this section we're going to divide polynomials by polynomials. So we're going to have large groupings of terms and we're going to be dividing by other large groupings of terms. And what you're going to find in this section is that it's going to look very, very similar to division that you did in third grade. You know, when you actually have the division line and you actually do long division, you know, that we learn in third and fourth grade. Your division of polynomials like this is going to look a lot like that. So even though I'm confident you know how to divide numbers, I want to actually review long division really briefly, take 2 minutes, because the parallels are going to be directly related to dividing numbers. So let's do a problem. I'll try to pick some big numbers so you're not too bored, but let's review things a little bit. Let's say you have 354. And you're dividing that by the number 27. All right, so we know that we can get a calculator and say 354 divided by 27, we're going to get some number. But how do we do it by hand? Let's do a little bit of a review. First thing you do is you take 27 and you try to see if it will divide at least one time into 3. There's no way 27 is going to fit into 3, so you can't do that. So then you look at the first two numbers, 35. Does 27 divide into 35 at least one time? The answer is yes. 27 is going to go into 35 only one time. So you put a 1 here. And you put a 1 over the 5 to signify that you were kind of looking at both of these digits here. Now after you put the 1 there, you have to multiply 1 times 27, which is going to give you 27. And then you draw a line and then you put a subtraction symbol there and you need to subtract the 35 minus 27. And when you do that, let me switch colors, 35 minus 27, I think everyone would agree, is going to be 8. So I'm going to write an 8 down here. Now after I do the subtraction, I look up in my original problem and I see if I have any more digits. And I do have a 4 that was unused, so I'm going to draw a dotted line with a little arrow. This 4 gets dropped down. Then I repeat the process, so it's kind of like an over and over again thing. I try to look, does 27 go into 84 at least one time? Yes, it does. I know it fits at least once. Does it fit 2 times? Yes, I believe it does. Does it fit 3 times? Well, you may not agree with me off the top of your head, but trust me, it does go 3 times. So I'm going to put a 3 up here over the 4 to signify basically that I was looking down here. It goes 3 times. And let's figure out what to do next. After you put your number here, you take 3 times 27. And when you multiply 3 times 27, you're going to get 81. So again, you draw your line, you draw your subtraction symbol, and you're going to subtract these guys. So let me switch colors again. What is 84 minus 81? Well, that's just going to be a big fat 3. So when you get done with this, you look up here and you see, do I have any more numbers to drop down? I don't have any more numbers to drop down. 27 cannot go into 3, so I'm basically done. So what I have figured out, the way you write this down, is that the answer to this problem, 354 divided by 27, is 13 with a remainder of 3. So that means that it can go 13 times, but I will have 3 left over after it goes and fits those 13 times. And to prove that to you, to kind of show you this, to check it, so to speak, if you take 13 times 27, you should get something that makes sense. So let's do 27 times 13, right? 27 times 13. When you do this and you do all the multiplication, you're going to get 351 as an answer. Notice that this is pretty close to 354. The difference between them is actually 3. That's because I had a remainder of 3. When I did my division, I figured out how many times 27 could go into the number, a whole number of times, but because they didn't match up exactly, I had a few left over. If I couldn't push it in 14 times because then I would have too much, right? So I go as far as I can, and then whatever gap is left over, I just label it a remainder. And that's what a remainder is, all right? Now, when you put a calculator to this and you take 354 and divide by 27 and hit enter, it doesn't give you remainders. It gives you 13 point something. So how do you get to that? Well, the way you really do it, the easiest way to understand division is to talk about remainders, but really what you do is you say the answer to this problem is 13 plus the remainder 3 divided by what I was trying to divide in my original problem, 27. 13 plus 3 over 27. That's what remainder is. You take the remainder, you divide by whatever it was you started with there in your original problem, and that is the other thing. Now, if you go and figure this out, this is 0.11111, and it kind of goes on, forever. I'll put a bar over it to let you know that it goes on forever. So really, 13 plus 0.111 is 13.11111. It kind of just goes on forever. So if you actually take 354 divided by 27 in the calculator, you're going to get 13.11111. The way you get it is by doing long division, getting your remainder, and then you say 13 is my answer, plus a remainder, but my remainder is really a fraction of what I started with. So it's kind of converting that remainder to a decimal, and that's what you see in your calculator display. Now you might say, why did I waste your time teaching you something that you learned a long time ago, right? It's because a lot of us don't do long division after we learn it, because we start using calculators, and you don't have to do these long division problems too much. But this process of looking in, seeing how much something goes, subtracting and doing it again and again and again is basically exactly how you're going to divide polynomials. So make sure you understand, at least kind of in a fuzzy way, how to do this. Let me erase the board, and we're going to go do some problems with algebra and with polynomials, and you'll see that the pattern basically is exactly the same. And also don't forget that when we find our remainder, the remainder is divided by whatever we were trying to divide in there. That is how the remainder is really set up, because when we do our algebra problems, it's going to look very similar to that as well. All right, let's say we have a problem, and it's x plus 2, and we're dividing into a polynomial x squared plus 4x plus 4. All right, now this would terrify most students if you didn't have someone to help you through it, is it looks really complicated. You have a polynomial and you're dividing by another polynomial. This is a binomial here, this is a trinomial here. So you're going to have to use long division. There's no cancellation tricks or anything like we did in the last section when you had simpler problem. Now we just have to roll up our sleeves and really do the long division. So let me walk you through it. The first problem we're going to do is going to be a little bit, I'll go a little bit slower, and then as we do the future problems in the section, we'll kind of speed it up a little bit so give you some more realistic, speed there. So really what you're going to do, to be honest with you, when you divide by something like a polynomial like this, you kind of ignore everything except the first term, really. I mean, you don't totally ignore it, but in the beginning you kind of ignore it, and you'll see what I mean. So what you need to figure out is you just kind of look at the first thing you have. How many times will x go into x squared? How many times will it go in there? And that might stump you for a minute. Let me just write the answer and we'll talk about it. It goes x times. How do you know that? Because if I go backwards and say x times x, I get x squared. Don't forget, that's what division is, right? If I say 10 divided by 5 is 2, then basically what I'm saying is that 5 times 2 is 10. So whenever I say this, x squared divided by this is x, turning it around, it's the same thing as saying x times x is x squared. So when you're trying to figure out what to put here, just figure out what do I need to multiply this by to give me x squared, and that's what I write up there. All right. Notice we kind of ignored the 2 here. We ignored all this stuff. We just looked at the first thing and then looked at the first thing there. Now we do our multiplication. We go down and multiply just like we did before. X times x gives us x squared. And then we have a plus here because of the plus here. X times 2 is 2x. Right? So we did our multiplication just like we did when we had numbers. We draw our line, we put a subtraction here, and now we have to subtract. And we have to subtract down in both columns here. So we have to first look here. X squared minus x squared is going to give you 0, so that you don't have to write anything for that. What is 4x minus 2x? Well, these are like terms, so I can subtract them. 4 minus 2 is 2. 2 what? 2x. So I did my subtraction. This subtraction came to 0. This subtraction came to 2x. All right? Now, once I've done my subtraction, I've kind of gone through one cycle. Then I look and see, do I have any more numbers or letters or anything here? And I drop it down, plus 4, just like I did for numbers. And then at this point, the cycle is reset and everything starts again. Again, I only look at x, and I only look at the first term here, which is 2x. How many times will x go into here? In other words, what do I need to multiply this by to give me this? And the only thing that's going to work is 2, because 2 times x is 2x, right? Now I'm linking it with a plus sign here, because because it's positive 2 really is what I've got here. So x times positive 2 is going to give me that. So now that I've got my number there, I do my multiplication down again. 2 times x is 2x. 2 times 2 is 4, right? So now I draw my line, draw my subtraction, and now I go ahead and try to subtract. 2x minus 2x is 0. 4 minus 4 is also 0. So let me go and just write a 0 here. And the problem's basically done now because I've done my subtraction, I've got 0 as a remainder, there are no more digits to drop down, and I've done all of my division. It does not matter that you don't have numbers on top of all of these things up here. Like a lot of times when you're doing long division with numbers, you usually have numbers like on top of all the other numbers under here. But for algebra, you basically just keep going until either you get a 0 remainder or until you exhaust everything that you can drop down, right? So the answer to this problem is x plus 2. So when you take x squared plus 4x plus 4 and you divide it by x plus 2, the answer you get is x plus 2. Now that's kind of weird. Why do you get the same thing? Well, it's just the way the division worked out. I mean, why is it that when you take 16 divided by 4, you get 4? Well, that's just the way it worked out because 4 times 4 is 16, right? So when you take this divided by this, you end up getting the same answer. Just so happens to be a coincidence in this case. And you can always check your work in algebra by checking, right? So we should be able to take this times our answer, and we should arrive at what we got here. So let's do it real quick. I don't want to do it for every problem, but x plus 2 times x plus 2. This is FOIL, binomial times binomial. So the first term is x squared. The outside terms is 2 times x. The inside terms is 2 times x. And the last terms is 2 times 2 is 4. Now I have x squared. 2x plus 2x is 4x plus 4. I have x squared plus 4x plus 4, which is exactly what I started with. This is exactly the same thing as when you say, 16 divided by 2 is 8, right? So you check your work by saying 8 times 2 is 16. You get back what you started with. So this is how you do long division. Every problem we're going to do after this is going to be modeled after this. It's going to be looking at the first item here, going into the first item here, and get your answer, multiply through, subtract. You do the cycle over and over again. Either you're going to hit a 0, in which it's over, and there's no more. Basically, you keep going until there's nothing else to drop down. And whenever you finally do the last one, either you're going to have a remainder of 0, in which case you have a pure division, or you're going to have a non-zero remainder, and we'll deal with that when we get to a problem, and I'll show you what to do when you actually get a remainder, but it's going to look similar to what you do when you have actual numbers. So let me erase the board, and we'll go on to our next problem. All right, now let's say we have y plus 1, and we're dividing into y squared plus 13y plus 12. And I'm going to admit, once you get the hang of it and you kind of get over your initial fear of how to do it and you kind of get good at it, it's actually kind of fun to see how it works. So first thing you do is you look only at the first leading term on the outside and divide it into this. Y times what can give me y squared? There's only one thing that works, and that's y, right? Now we've got something at the top. Now let's multiply. Y times y is y squared. Y times 1 is y. So we've got all our multiplication done. We draw a line, we draw a subtraction bar. Okay, y squared minus y squared, 0. 13y minus 1y is 12y. So I've done my subtraction. Once you get that, you look over and drop whatever you have over here down. Don't forget your plus sign from there. And the cycle starts over again. You look at the first item. How many times will y go into this? In other words, y times what will give me 12y. There's only one thing that works, positive 12, because 12 times y is 12y. So we do our multiplication. 12 times y is 12y. 12 times 1 is positive 12. So now we draw our line, we draw our subtraction. And now we go ahead and subtract the results. 12y minus 12y is 0. 12 minus 12 is also 0. So I get a 0, and there's nothing else to drop down. There's nothing else to divide. I have a remainder of 0, and I'm done. So the answer to this division problem is y plus 12. So the way you would say this in words is y squared plus 13y plus 12 divided by y plus 1. The answer is y plus 12, and there's no remainder. In other words, this division worked out perfectly, and there was nothing left over. All right, what if we have 10x squared plus 11x plus 3, and we are dividing into this 5x plus 3. All right? So we do the same thing we did last time. We only look at the leading term and divide it into the leading term. 5x times what can give us 10x squared? Well, I have to have a 2 in there because 5 times 2 is 10. X times what gives me x squared? You have to have an x there. So that's our first step. Now we do our multiplication. 2x times 5x, we just said, is 10x squared. 2x times 3 is 6x. 2 times 3 is 6. X comes along for the ride. Draw our subtraction bar. This minus this just gives me 0. 11x minus 6x is going to give me 5x. And I've done my subtraction, so now I just look over and drop anything down that's the next guy over with a plus sign, and the cycle starts over. 5x divided into 5x can only go one time, positive one time, so I draw that up there. And now I do my multiplication. 1 times 5x is 5x. 1 times 3 is 3. Draw a line, draw a subtraction bar. I think you can see 5x plus 3 minus 5x plus 3 is going to give you 0. So there's no remainder. There's no more digits to drop down, so I'm done. So the answer is 2x plus 1. When you take this division and do it, you get 2x plus 1, and there's no remainder. All right, let's say we have 2x minus y on the outside, and we're dividing into 6x squared plus x times y minus 2y squared. All right? Again, it's the same song, different verse. So we have the first leading term divided into this. 2x times what will give us 6x squared? Well, the only thing that works is 3x, because 2 times 3 is 6. X times x gives me x squared. So now that I have it there, I multiply. I'm going to get 6x squared. 3x times negative y gives me negative 3xy. So now I do this, and I subtract. So 6x squared minus this gives me 0. Now you have to be careful sometimes. This is a like term with this, so I can subtract it. But what you've got going on here is xy minus a negative 3xy. So just this one time I'll show you. What you have here on the side is xy minus a negative 3xy, because you're subtracting a negative value. So this is like adding. Basically add the opposite. So really what you have is 1 plus 3 is 4xy. You have to be careful. Anytime you get a negative number down here, you got to be careful to kind of flip the sign in your head and basically add it. Otherwise you're going to get the wrong answer all the time. All right? So we've done the subtraction. Now we just drop down what we have here, negative 2y squared. And then we repeat the process over again. How many times will 2x go into here? Well, 2 goes into 4 2 times. I don't need an x, but I do need a y, right? Because 2x times 2y is going to give me 4 times x times y. So you're kind of going in reverse. You look at this, you figure out what you need to write up here in order to get what you have. Now that we've done that, we do this multiplication. We just said we'll get 4xy. This times negative y is going to give me negative 2y squared. Now I do my subtraction. And again, you have to be careful. 4xy minus 4xy is 0. Negative 2y squared minus a negative 2y squared is like basically making this plus. So negative 2y squared plus 2y squared is going to give you 0. So what you have here, just one more time to show you, negative 2y squared minus a negative 2y squared, because you have a minus negative. And so basically you're adding these guys together, and that's why you get 0. So in the future, I'm not going to, as a sidebar, write this stuff. You need to kind of do that as you go, but I want to make sure that that sign error doesn't get you there. So the answer to this problem is 3x plus 2y, and there's no remainder. 3x plus 2y, no remainder. All right, so what we have next is 3x minus 2y, and we're dividing into 3x squared plus 13xy minus 10y squared. All right, so it's the same thing. We look at the beginning term, 3x, we divide it into there. The only thing that works there is a single x, because 3x times x is 3x squared. And so we do that multiplication, we get 3x squared. X times negative 2y is negative 2 times x times y. Draw our line, draw a subtraction. This minus this should always give you 0. And then when you have 13xy, you're subtracting a negative number, so you're basically adding 2. So 13 plus 2 is 15xy. You got to be very careful to make sure you do that properly there. So you have that. Now you drop down the next value that you have, 10y squared. And then you look and see, how many times will 3x go into this? Well, 15 divided by 3 is going to give me 5. I have an x here and I have an x here, so I don't need that, but I need to put a y up here, because 5y times 3x should give me 15xy, which is what I'm trying to reach here. So you're kind of going backwards. What do I need to multiply this by to give me this? So when I do that multiplication, let me switch colors, I'm going to get 15xy. And then over here, 5 times negative 2 is negative 10. Y times y gives me y squared. So I subtract, right? And so you can see that I've got 15xy minus 10y squared, and I'm subtracting off the same terms. So everything is basically going to cancel. You can think of it either way. You can think of this as 15xy times 10 or minus 10y squared, subtract off the same thing is going to give you 0. Or you can do what I said to begin with, which is for this guy here, you're kind of subtracting a negative, which makes it positive, so you're getting 0 either way. It's however you want to think about it. So the answer is x plus 5y. X plus 5y, no remainder. All right, the next problem is going to be 3x plus 2 divided by 6x cubed plus 10x squared plus 7x plus 2. So there's a couple things going on here. The first one is, I'll just tell you ahead of time, this is the last problem that we're going to get a 0 remainder. The couple problems after that we'll have a remainder to deal with. Second thing is, I have 4 terms on the inside. This polynomial is actually bigger than any of the ones we deal with, but the pattern is repeating, and so it's all the same. You look at 3x, how many times will it go into 6x cubed? The only thing that works is 2x squared, because this times this should give me that. So when you do that multiplication, you get 6x cubed plus 2 times 2 is 4x squared. Draw a line, draw a subtraction. And then underneath, this is 0. 10 minus 4 gives me 6x squared. And then once I'm done with that, I drop the next guy down, 7x. And I repeat the process again. How many times does 3x go into 6x squared? Well, it's got to go 2x times, because 2x times 3x gives me 6x squared. So I do that multiplication, and then this times 2 should give me 4x. Draw my line, draw my subtraction. Now, this gives me 0. 7 minus 4, since these are like terms, is going to give me 3x. I've done my subtraction, now I look for the next term and I drop it down. So there, a 2 comes down, and I repeat the process again. So you see it's kind of an infinite thing, it just keeps going. 3x goes into 3x only one time, so I put a plus 1 up here. Do my multiplication, I get 3x plus 2. Do my subtraction. Of course, when I subtract these guys, I get a 0. So I've got no more remainder, nothing else to do, no more numbers or letters to drop down. So I'm basically done. So the answer, 2x squared plus 2x plus 1, and there's no remainder. 2x squared plus 2x plus 1. Now, in the next couple problems, we're going to be doing the long division, but we're going to find out that once we get down to the end, we are going to have a remainder. So they're really done exactly the same way. It's just that at the end we'll have to figure out how to deal with that remainder. So it's not going to be that big of a deal. Let's say we have 2x plus 3, and we're dividing it into 2x squared plus 5x plus 2. So the problem doesn't look any harder than what we've done. Just like some division problems don't look too hard, but you know, they lead to remainders sometimes. So how many times will this go into this? The only thing that works is x, because x times x gives me x squared. So when we do this multiplication, x times 2x, I'm going to get 2x squared. X times 3 is 3x. So I draw a line, draw a subtraction. And I do my subtraction. This gives me 0. 5 minus 3 gives me 2x. Now I've done that subtraction. Now I drop down my next guy, just like I've always been doing. And I repeat the process again. How many times will 2x go into 2x? Well, it only goes one time. Let me change colors. 1 times 2x gives me 2x. 1 times 3 gives me 3. So I draw my subtraction. 2x minus 2x is 0. What is 2 minus 3? Answer is -1. So I get a number down here. There's nothing else to drop down, so your problem basically stops. Once you've already pulled down your last thing and done your last bit of division, there's nothing else to do. You've run out of things. You've divided everything out. This is your answer, and what you have down here is your remainder. So basically the way you write the final answer is what you have on top, x plus 1. And then you have to take your remainder, which is -1, and divide it by what you were dividing by, 2x plus 3. So since you have plus minus, it's probably easier to say x plus 1 minus 1 over 2x plus 3. And this is the final answer, x plus 1 minus 1 over 2x plus 3. And just to totally drill it home, this is exactly like, let me switch colors. This is exactly like saying 5 and dividing by 2, right? How many times does 2 go into this? Well, it goes 2 times. 2 times 2 is 4. I subtract and I get a remainder of 1. There's no more digits to drop down. There's nothing left. So what I have found is that the answer is 2 from here plus a remainder of 1. But the way you write it in terms of what a calculator would return is 1 divided by this, 1/2. 1 divided by what I was dividing by. So what you would get is 2.5 in a calculator, so 2.5 times. So the number 2 goes in here 2 whole times plus another half. That's how you get a fractional at the end. So this guy gets divided in x plus 1 times plus, and then you have a -1 over 2x plus 3 as your actual remainder. So calculators can't really do this so easily, but if you would type it in, this is the kind of thing you would actually see. So the remainder is -1, but you express it as a fraction because it's kind of saying how many times can this go in, plus how many fractional times can this come in after you're done, just like we did for numbers. Okay, here's our final problem. It'll be kind of long. X minus 2 divided by 2x cubed plus 4x squared minus 2x plus 3. Okay, so there is our division problem, but we're doing the same thing each and every time. So we look at the x and how many times will it go into 2x cubed. What do you have to multiply up here to make that happen? We have to multiply by 2x squared in order to make that happen. So we do this multiplication, we're going to get 2x cubed, right? And then we do this multiplication. -2 times this is -4x squared. And now we do a subtraction. So, of course, this subtracts to 0. When you do this subtraction, you need to be careful because what you have is 4x squared minus a -4x squared. So it's like adding 4x squared. So really what you get is 8x squared because this changes into a positive when you subtract a negative number like this. So you get 8x squared. And then you drop this down, minus 2x. And then the process starts over. So how many times will x go into 8x squared? It goes positive 8x times, because this times this is going to give me that. So when you do that multiplication, you get 8x squared. And then 8x times -2 is -16x. Draw your line, draw your subtraction. Now, of course, 8x squared minus this is 0. Now, what is -2x minus a -16? And I will write this off to the side to make sure it's clear. -2x minus a -16x. You can add the opposite here. So really what you have, -2 plus 16, or if it's easier for you, 16 minus 2. So what you're going to really have, even though it doesn't look like it, is 14x. That's what you have. And then you take the next digit over and you drop it down, make it plus 3. Okay, and then process starts over. How many times will x go into 14x? can only go 14 times. We do the multiplication, we're going to get 14x. 14 times negative 2 is negative 28. So we do this, we draw our line like this. 14 minus 14 is 0, and then what we really have here is 3 minus a negative 28, which is like adding a 28, basically, because you can add the opposite. So what you really have is 31. 31 is the final thing at the end, and there's no more digits to drop down. So the process keeps going until after you've done the subtraction, you can't drop anything else down. This is the answer, this is the remainder. So the way you write it down as a final answer is you're going to have 2x squared plus 8x plus 14. This is the whole number of times it divides in, plus 31 as a fraction of what I was trying to divide in, x minus 2. So this is how many whole times it can go in. This is how many fractional times it can go in. We've talked about what that means. So 2x squared plus 8x plus 14 plus the remainder, which is 31 over x minus 2. And that is it. We are done with this section. We have learned how to divide polynomials by other polynomials. And you can see that it follows the exact same pattern that you learned in 3rd and 4th grade when you're dividing numbers by other numbers and you're doing long division. So we've reviewed that. We've done lots of problems here. You just keep going with the process until you basically run out of things to drop down from your original problem. If you have a remainder of 0, then it's like saying 10 divided by 5. The answer is an even number of times with nothing left over. If you end up with something at the end and you've exhausted your problem, then that's the remainder. And I've showed you how to set that up as a fractional part of the answer there. And so, you know, it is kind of a little bit cumbersome, but I tried to give you enough examples so that you can get some confidence. So make sure and work these problems. Make sure you can get them all correct. Go get some extra problems either in my worksheet pack or in your textbook. Work those, make sure you understand those, and then follow me on to the next section where we will continue working and building our bedrock knowledge and tools for algebra.